Hi folks, welcome back to 6.2 Disc and Washer Method. In this video we're going to look at question number 9. Question number 9 says, find the volume of the solid of revolution generated by rotating the area of the graph of f of x equals x squared and g of x equals 4, and this should say about the line y equals 5. So this is our axis of revolution, okay? So this above should say about. Okay, so let's start with our graph. Got a graph of x squared, again, one of those graphs that we should know pretty well. 0, 0, 1, 1, 2, 4, and negative 1, 1, and whoa, negative 1, 1, and negative 2, 4. And so this is my f of x. My g of x is y equals 4, or right here. Okay, so I've got a nice enclosed area. I want to revolve it about the line y equals 5. All right, so let's draw our reflection. Our reflection is going to go like this, and then if I reflect all the points, I'll end up with something kind of like this. Okay, now when I look at this, I notice there's a gap between the green line, my axis of revolution, and the shape. So automatically I'm thinking washer method because I have a hole in the middle. So I need to think area of my washer equals pi big R squared minus little r squared. Now let's draw our washer. So which color is further away from the green line, the purple one or the pink one? And I think most people would say the pink one. And so the pink one is our outer radius because it's further away. So my washer has an outer circle that is pink. I don't know why that does that. All right, it has an outer circle that is pink. All right, now the inner circle that I'm going to be subtracting is the one in the purple. So my inner radius, or my little r, is purple. Now let's just confirm this. So these would be the radius, the radii for any given slice, and that represents this distance right here. Okay, so now let's set up our integral. So my volume equals the integral of area, and because my blue lines are perpendicular to my axis of revolution and they're stacking along the x-axis, we're going to call it dx. And we know then that our bounds are x values from a to b. So I can say the integral from negative 2 to 2 of pi, the pink curve, squared, that's my big R, minus my little r, we're going to do 5 minus the pink curve, which is 5 minus x squared. This is going to be squared to give me my big R squared, minus 5 minus 4, which is the little r squared. Okay? Now we're going to go ahead and we're going to do two things at one time. I'm going to change the bottom bound to 0, and I'm going to double this, and I'm going to take the pi out. So 2 pi, the integral from 0 to 2 of 5 minus x squared squared minus 1 squared dx. All right, looks like we have to FOIL a little bit before we can take our integral. So 25 minus 5x squared minus 5x squared is minus 10x squared plus x to the fourth minus 1 dx. I'm going to combine some more like terms. 2 pi, the integral from 0 to 2 of 24 minus 10x squared plus x to the fourth dx. All right, let's integrate. 24x minus 10 thirds x cubed plus 1/5 x to the fifth, plugging in 2, plugging in 0. All right, now I'm not going to plug in the 0 because I know from looking at it that when I plug in 0, it's going to give me 0. So I'm only going to plug in the 2. So that will give me 2 pi 24 times 2 minus 10 thirds times 2 cubed plus 1/5 times 2 to the fifth. And I can even say minus 0 if I want to remind myself what happened to the second part. All right, let's finish. 2 pi, 24 times 2 is going to give me 48 minus 2 to the third is 8, so I have 80 over 3 plus 32 over 5. So looks like I'm going to put everything over 15. And so I have 15 minus 15 plus 15. All right, so 48 times 15 is going to give me 720. 80 times 5 is going to give me 400. And 32 times 3 will give me 96. And that's going to give me 720 minus 400 plus 96. Or it will give me 2 pi times 416 over 15. And that I can multiply out to give me 832 pi over 15. And that simplifies, no, it doesn't simplify. So we're just going to leave it as 832 pi over 15. All right, so this is a case where we have that axis of revolution not at our axis, like an x-axis or a y-axis, so that's why we need to adjust for it like we did here. All right, we got one more practice problem to take a look at, so come on back and take a look at the last video for question number 10.